The ear has a remarkable ability to handle an enormous range of sound levels. In order to express levels of sound meaningfully in numbers that are more manageable, a logarithmic scale is used rather than a linear scale. This scale is the decibel scale. The sound intensity level, L, is given by the formula below. L is equal to 10 log to the base 10 of I divided by I naught decibels, where I is the sound intensity and I naught is the reference sound intensity. I and I naught are measured in watts per meter squared. Listening to a sound intensity of 5 billion times that of the reference intensity, I equals 5 times 10 to the power 9 times I naught, that's 5 billion times I naught, for more than 30 minutes is considered unsafe. To what sound intensity level does this correspond? Okay, so let's just substitute in. L is equal to 10 log to the base 10 of 5 times 10 to the 9 I naught divided by I naught. The I naughts will cancel there. So we've just got 10 log 5 times 10 to the 9. And if we calculate that, that is 96.99 decibels. The reference sound intensity, I naught, has a sound intensity of 0 decibels. If a household vacuum cleaner has a sound intensity of I is equal to 1 times 10 to the negative 5 watts per meter squared, and this corresponds to a sound intensity level L of 70 decibels, determine I naught. Again, this is just substitution. We know that 70 is the level, and that is going to be 10 log, and that will be 1 times 10 to the negative 5 divided by I naught. The only unknown here is I naught. Just solve on the class pad and we get I naught is equal to 1 times 10 to the negative 12. And that shall probably give units, watts per meter squared. The average sound intensity level for rainfall is 50 decibels and for heavy traffic is 85 decibels. How many times more intense is the sound of traffic than that of rainfall? So what we can do is say, well, 85 is equal to 10 log, and let's call this intensity I1, divided by what we now know is 1 times 10 to the negative 12, and solve on the class pad, and that gives me I1 is 0.00036162. Do the same thing for the 50, and that is 10 log, let's call this one I2, 1 times 10 to the negative 12, and solve for I2, and that is 0.000001. And so we want to do I1 divided by I2, which is just this divided by this, and it gives us 3162.3. So it's 3162.3 times as loud. In the mark scheme, they just gave 3200, so you were allowed a fair bit of margin.